Hello, my name is Divyang Vaidya, and this will be EE104 Lab 4. This is the airbag coding project. So for my airbag coding project, I've chosen the def airbag cart, the function which is 22,000 over t minus 74 to the power of 2 plus 500. This is the function I chose because we can get our maximum value of d is equal to 50 at 315. So for the Mercedes-Benz, this with the airbag, the collisions are proven to be a little bit more safer. And so yes, so the def airbag cart is this function here. Function is equal to lambda tau 22,000 tau minus 74. The two asterisks means it's the power of 2, so it's an exponent plus 500. So that's just the function declaration, the declaration of the basically of uh, the the exponential function that we have. And the function 2, ER is equal to integ the dot quad function t plus d. That's basically saying that, okay, we want to integrate this function. So this function is going to be integrated. So HIC is equal to d star 1 over d star function 2 star 2.5 over 1000. That is the HIC value. So for each of these HIC values, we're going to get the maximum, and we're going to be able to plot it like this. It's going to be a curve. So for the time range, SV is equal to T for T in range 160. We're just declaring the range, which is the axes from 0 to 160. So we're going to plot this across that range. So XI30 is equal to airbag dash cart T30. So we're setting the first maximum value for 30. So that is our first value of D. And we're saying it's for T in this range. So this is the range, and we want to plot it within that range. So that's why it says for T and SV is declared as T for T in range 160. So these values are all going to be plotted within that range. So XI40, airbag cart T40 for T and SV. That's basically saying, okay, we're going to plot uh, the value T is equal to 40 across the range of 0 to 160. So that's why
It's 11
we're
o'clock.
plotting it there. XI50 is equal to airbag dash cart T is T50 for T and SV. That's basically saying our maximum peak value is D is equal to 50, max 315.7. So that's T is equal to 50. So within the range of 0 to 160. So this function right here, get max HIC values, those declarations are saying, okay, we want to print the max value for D30, print the max value for D40, and print the max value for D50. So the variables for that were XI30, which is XI30 is right here. So the maximum decimal point for that value, the floating point value, we want to print that, and we want to set it to D30. And then we want to print the D40 value for the maximum for I40. So that is at D is equal to 40. And then at D is equal to 50, we want to set the maximum value and put it at D is equal to 50. PLT.figure. This is basically saying plot the figure Mercedes-Benz with airbag. So this is going to be the figure. Um, uh, and then we're going to plot the x-axis time milliseconds. So that's right here. And we're going to plot the Y label, which is HIC, which is right here. So those are just the axes titles, essentially. Similar in Excel, where you would have to plot the x-axis titles. So it's the same concept. And then we're plotting the HIC curve. So plt.plot SVXI30, orange label FD30 max D30.2F. So we're basically saying, okay, we're going to plot the first value of XI30, the first D30 value, and we're going to set the color to orange. So that's this one right here. And we're going to say a label is equal to FD.30 max D30.2F. So we're saying, okay, we want to print the maximum value, the decimal value, the floating point value for D is equal to 30. And we want it to have two decimal places after. So 0.2F is like a precision. So that is 0.53. PLT.plot SVXI40, comma red. Label is equal to FD40, max is equal to D40.2F. That's right here. D is equal to 40, max 308.84. PLT.plot SVXI50, magenta, label FD50, max D50. That's again saying, okay, now we're plotting the magenta value. So the magenta value is right here. And again, we want to declare that as D is equal to 50, max 315.57, or 17 rather. So plt.legend. So this is the legend that's showing in the plot. And plt.show. So this is essentially saying to Python that, okay, we want to plot the legend, and you want to show the plot. Um, I think I covered red, but the red plot is right here. So again, that's saying D is equal to 40, max 308.84. So that's for those three plots. And the reason I chose the airbag.card value is because at D is equal to 50, we're at our maximum right here at the peak. So it's proven to be the most safest among for the Mercedes-Benz. This is for the Mercedes-Benz car. Thank you. Have a good day.